Thank you. We are with a small group, so let's make this interactive. If you have any questions in between, shoot. Okay. Thanks for joining us this evening. I want to talk to you about CRaC, which is a project to speed up Java at startup. But more importantly, because I documented a lot about CRaC, I also want to share with you what I learned about the OpenJDK project itself and Java and all the tools that we are using. You can find me on Mastodon on fujay.social. That's my colleague Geert-Jan. He's coming from Amsterdam. And I have to add this disclaimer. The CRaC I will be talking about is coordinated restore at checkpoint. I was talking at the conference with some people in the speaker's dinner about distributing CRaC and using CRaC. So it's not that type of CRaC that I will be talking about. What I will be talking about is this, and what I learned from this curve. So I will go into details about this, but this is warm-up of a Java application and why it is important and what we should know about this as a Java developer. And CRaC, as I said, the aim is to speed up the warm-up of a Java application. And with the first tests that we did with this approach, we could speed up the startup of a Spring Boot application from 4 seconds to 40 milliseconds. So, and that's the same results we now get with the final product. So this is quite impressive. Also talk about why this is important. And as I mentioned, it's not only about CRaC. As mentioned before, we already had a presentation about CRaC at the BJUG event some time ago in Kortrijk. But it's also what I learned about OpenJDK and what's in that project, what I find so interesting. As I said, let's make this interactive. If you ask a smart question, I have this Duke. I have 3 of them. So that's the challenge towards you. On azul.com, Duke brick builds, you will find the instructions how to build this. If you want, you can order them, but I have 3 of them. But first I have to give you some history about myself. I'm this old. This is my first computer. And what I find amazing about this device still now is that I was able to control my Lego train with it. So already at that time, I found in a book a board that you could attach to this Commodore. And when I was, I think, 14 years old, I was controlling my Lego train from software points. So I hijacked the joystick port with magnetic switches to know where my train was, that I could really control it and visualize it on the screen, which was the start for me into programming. I only had one game. It was with this big block that you had to put in the machine to have your game. But I actually did more programming than really playing games with it. And I graduated here in Brussels in '94 as a film editor, actually. So I did film school. I did an engineering school, television technology. And I went through this whole phase of evolutions into the digital world. I started as an analog video editor, then became the computer editing. I have been one of those annoying flash skip intro animators. Some people share the same history. But I became a software developer again in this career. And why is it important that I tell you this is I'm not an educated software developer. I just became one. I never got a training. I never followed school. I learned stuff by joining meetings like this and conferences. So I was an active Java user without knowing that there was an OpenJDK project and what was happening in there. So those are things I learned only recently. 4 years ago, I started this pet project, which is the drum boot of my son, and I wanted to create a touchscreen controller for him. So I wanted to do that with Java and JavaFX because I already knew that, and I combined it with a Raspberry Pi, with an Arduino, you have LED strips. And because I already knew how to do this with Java, I could build the user interface, and I learned, again, the same things I did with my Commodore 64, controlling hardware. And because it's Java, I could add an API to tell him that dinner is on the table and he has to stop drumming. But that's also how I became the Java on Raspberry Pi developer, because I was experimenting with all this, and all this ended up in a book. I started writing articles taken out of this book for a website started by Geert-Jan Fouget. I will also show you. And that's how I ended up as being Java on Raspberry Pi and writing about all this. And finally got me a job at Azul. So Azul is one of the distributors of OpenJDK. Azul Zulu. Zulu is maybe a well-known name. Zulu is our free version of the OpenJDK distribution. We also have Prime, which is aimed at Linux systems, heavy Linux systems, where you want very low latency, typically used in banking, stock exchange, that kind of stuff. Chess.com is also, chess.com is also running on Prime. You don't want people waiting for seconds for a move of their chess pieces because the garbage collector is doing something. That's what we solve with Prime. And we also have some tools around Java. So Azul is really a Java-oriented company. We only do Java. We do support, we do licenses, but only Java. And it's also within this company that the CRaC project was born. If you are interested in the state of Java, we have a very nice report that we published, I think 1 month ago, something like that. You find it on the azul.com website. I invite you to find it there. So what is the story? What is my history? I am a Java developer. I have been doing Java development for over 10 years at a few companies. And since joining Azul, my colleagues are the people who created Java. They have been working for Sun, for Oracle. They have been inside the Java project from many years. He's as old as me, I think so. So it gave me insight in how the OpenJDK project works, how things are evolving. I am now half of the docs team of Azul, so I'm writing the release notes. I'm writing the documents describing what is new in Java 21, in Java 22, which is coming in a few months. Also what's happening in the security updates every 3 months. So I can really understand now and see what's happening inside the OpenJDK project. Just a fun story, my very first assignment when joining Azul was writing a blog post about the garbage collector. There are 6 garbage collectors. It took me 3 months to finish that article because I could ask to 6 different engineers at Azul who have been working on the garbage collector from the very early days, and they all had different opinions about what should be in the blog post. They were all right, of course, but and thanks to all this work, since this year I'm also a Java champion, one of the 7 or 8 of Belgium Java champions. So very proud of that I got honored with this trademark. So I want to share some things I learned with you. One is a very stupid tool, very easy tool. Who knows SDK-man who's using it? It's really easy if you're on Linux or on Mac OS and you want to switch between Java versions. Just try out one of the new ones very quickly. If it works with your code, use SDK-man. You will see some screenshots that I've taken using this tool. And before I dive into the details of this project, there's something you need to understand about the difference between Java and OpenJDK. They're not the same. The main thing of Java, it's a trademark. It's something registered. It's owned by Oracle. A little fun story is this Raspberry Pi project that I was involved, Pi4j, which is a library to use Java on the Raspberry Pi. In the logo we had the coffee smoke, and I got a message from Oracle that the logo should change because that's part of the trademark. So you have to be really careful what you do with this Java trademark and all the branding around it, because that's really owned by Oracle. It's also the name of the programming language, and it is defined in the technology compatibility kit. Now what is this? This is a set of tests you need to apply to if you make a version of Java. So what Azul is doing with every new version which is being released, every version on every platform, on every processor, is tested against this technology compatibility kit. Otherwise, it's not a valid Java runtime. Okay? I think we run about 1,000 tests during 1 month before we can release these packages. So, on my mother's birthday, the 16th of January, we have the next security release. That means that my colleagues are already solved security issues in that version and are testing all these builds so that they are ready by then. So this is a very important thing. So if you're looking for a distribution of Java to use in your environment and you don't want to have problems with licensing, for instance with Oracle, make sure that you're using a version which is TCK compliant. So what is OpenJDK then compared to Java? OpenJDK is actually an implementation of this Java specification. Just like GraalVM, you could see it as an implementation of Java. OpenJDK is also one. So it implements the Java programming language, the virtual machine, the core libraries, everything can be found in OpenJDK. And this is open source. So this is something you can grab from GitHub and do whatever you want with it. Use and modify it. But again, if you want to distribute it as being a Java runtime, you have to be TCK compliant. Okay? Go to github.com/openjdk, and there you have the whole thing. So this is the source of all the Java we are using as a programmer to make our applications and also to run them. Okay? So here, JDK, that's the project you want to be if you want to learn and see how Java actually is made. And I don't know if my connection is good. And you see that, yeah, a big part of this is actually written in C and C++ because, yeah, that's the runtime there. But you see that there are a lot of repositories within this project. So there are different projects ongoing within OpenJDK. And one of them is CRaC. I don't know where it is in the list. Here's CRaC. So CRaC is a fork of OpenJDK, which has additional technologies because it's not yet an official OpenJDK project, but we'll come to that later. So you can grab OpenJDK from GitHub and build it yourself. That's one of the ideas you can do. And I've done that on a Raspberry Pi. Of course, because that's my experiment device. I don't have a license in, and I don't want to make all these cloud providers rich. Raspberry Pi is a Linux device. It's not that fast as most machines that you can find on Amazon, but you can do everything you know with the Linux. So if you have the normal Java installed on a Linux system and you ask the version, in my case I had already 21, but I took all the sources and I have described it also on my... So you need to install a lot of tools to make it compile, but actually it's just copy pasting. It's in the README file also of OpenJDK. You can just, if I can do it, you definitely can do it yourself. So after an hour and a half, I have a build of OpenJDK. It takes some time. And if I then ask the version of Java, I have version 22, which is to be released next year. So you can already start experimenting with version 22. And this was actually the CRaC version of 22. So we're already a few steps ahead. So OpenJDK is there on GitHub. You can dive into it. You can look how it's created, how tickets are solved, how changes are implemented. So it's a really fun thing to do if you have some time, and you can play with it. Now, another important thing about Java is an upgrade versus an update. So we all know that we have these versions. Every 6 months we get a new version. Most companies stick to the long-term support versions because they are well supported, but actually 20 and 22 are just as good as 21. The only thing is they will not be maintained and updated a very long time. That's why you have to stick in most companies to the long-term support version. But the update is pretty important. You can be on version 17. Who is on Java 17? Who's using 17 in production? Okay. You have any idea which version of 17? 17.0? 03.
Of the Tenerin.
We are at 9. Every 3 months there is a new one. Every 3 months there are security fixes in there. So that means 6 versions ago, so it's a year and a half. Yep. Yeah. I don't want to scare you. So this is part of my job, is creating these document sets. So this is the October release we just had a few months ago. So you see here that we are on 17.09. And then if I go to the security fixes, then there are 5 issues security related. 2 of them were GraalVM, so that was not an issue for our runtime, but 3 are really part of OpenJDK and were infecting OpenJDK builds. And there were network issues. The score is between 1 and 10. If it's 10, then yeah, everything is 10, then yeah. Log4j and similar things. But this was in October, so I think if I go back to, was it July? To the release notes. In July, 1, 2, 3, 4, 5, 6, 7, 8. So I only checked 2 of the versions of the 6 version that you are behind. So keeping your runtime up to date can be very important. So you get security fixes, you get bug fixes, and sometimes there is even a backport of something which was introduced, for instance, in 21, and they say, yeah, we really need it in 17. Then that can happen, but it doesn't happen a lot. But that's something that you can get with all these newer versions. So you see, with SDKman, I checked for the version 17, which were available for my system only from Zulu, and you see that there are already multiple there. So 17.09 is the one in October, and that means that in January it will already be 17.010. Okay. I do the docs. I only know which security issues there are 1 hour before I publish the docs. So that's really something which is handled very well. So Oracle is involved, Azul is involved, Bellsoft, and a few other companies who make this Temurin, but only a very limited set of people is aware of these security issues. So these are issues which are reported already some time ago, and each time when they start a new build or a new version, they pick out the most critical ones that should be solved. Now, also, I'm not selling Zulu here, but that's the company I work for, so I talk a lot about it, but there are many more distributions. You know which distribution you're using? Are you aware that there are different possibilities there? So again, with SDKman checking the 17.09 versions, so these are the distributors of OpenJDK, which have a version, in my case, for my Mac. So we have Amazon, we have Graal, Liberica, Microsoft, Oracle, Submachine, Temurin, Zulu. So there are a lot of distributions available there. And why is it important which version you're using? You've probably heard about the Oracle licensing story, that they changed the whole model. So a lot of companies want to step away from Oracle. you have a lot of options there. I also have a book. I have 3 of them, and they are signed by the author, which is Simon Ritter, also a colleague of us, but he's known on Twitter as Speak Java. He's the CTO of Azul, but he has written this book. It's not a sales book for Azul. That's clear. Of course, he talks about Azul, but it's really about why is it important to know which distribution you're running on which update, which licensing model is involved, and all that kind of stuff. So all this is important there, and you should be aware of it. Okay. Now, let me share you one story about OpenJDK that I learned by writing the docs, and that's the time zone and currency database. And I've written it down in a blog for Azul. And the idea of this blog, I will come back to that later. So there is a whole database inside OpenJDK with information of countries, currencies, time zones, stuff like that. So for instance, this is using version 17. JShell, you're using that? Have you used it before? It's a very handy tool to do stuff like this. If you want to experiment with Java code, this kind of stuff is very easy. So there are 603 time zones defined in OpenJDK. So it's not a database it loads from somewhere else, it's inside OpenJDK. So it's Europe, Belgium is somewhere in here, and then all the other countries. So all that information is part of OpenJDK. And it's really fun to read this. This is on GitHub. So if you go to GitHub, I think I have it open here somewhere. So inside the OpenJDK project, if you dive into it's really deep. Huh? It's 5 directories deep. You have the TZ data per region, and then you have this very long file. Goes on, goes on, goes on. And it's really, it's a history book. It's not source code, it's a history book. It defines, it tells you, like in, just random, in Czechia, in these years, 1947 till 1948, we had a daylight saving which has changed in 1948. So there's really a lot of information there. And it's actually fun to read. Like this is some part of the rules for Belgium. So if something changes in the time zones in daylight savings, God help us that we get rid of the daylight savings. But if we get rid of the daylight savings, it will be here. There will be a line here. So you can really read that in the sources of the OpenJDK project. And that's one of the lines we have to add to each release note. The version of the time zone database in this release every 3 months. For instance, in January, it was 2022G. Now, what does this mean? Where does this come from? Actually, there is the IANA project, IANA.org, I think, which is an open source project again, a community project, where they keep a list of all the time zone and related data. And all the changes which happen in this project get ported to the OpenJDK project. So everything which is changed in OpenJDK is based on this. And if you look into the changes of January 2023, it's not only time zone data, but for instance also currency and some country-specific things. Like something changed for Sierra Leone, something changed for Turkey, and there was a currency change for Croatia. And actually, this can break your code. This can break your unit tests. What's happening with version 1901? I define a currency, HR is the code for Croatia. I have no idea why. Some will have a reason, but I don't know the reason. If you ask for the currency, then you get the Croatian kuna, which is the currency of Croatia, or better, it was. Because if you do exactly the same thing with 1902, you get the euro. Apparently they joined the euro region. So if you have a program with a shop which is running on Java and you're getting the currency from the country, you would imagine that you have to change your code, but it's not true. You have to change your runtime. Or if you have this in unit test and you change the version in your build system, you can break your unit test because something changed here. But that means that the whole project and using the latest Java has another important reason. It keeps you up to date with currencies, with time zones, with daylight savings. That's all inside there.
For every vendor, this 1902 is for Azul, and for other vendors, exact the same currency. It's not if you Azul, then
so it's an OpenJDK project, and that's a whole different story. Like, so you have the long-term support versions and the short-term support versions. So I think Oracle is in control for 6 months. So 19 gets released, they maintain it for 6 months. And then they ask to the community, who wants to be in the lead? And Azul is, for instance, the lead for a few versions. I think it was 13 and 15, yeah. They were in the lead. So they kept it up to date for some time and then decided, yeah, now it's long enough, now we move to a newer version. So indeed, everyone is taking a copy of GitHub from that moment, and that's 1902 is all based on the same sources. Yeah. To make it more complicated, with Azul Zulu we have different version numbering, but it shows you this number. Okay, so it's inside there, but we have our own because we make more builds. If our customers find a bug in Java, I always tell developers, good luck with finding a bug in Java. It's probably in your code. But if you find one, who are you going to call? Who is going to solve it for you? You can make an issue in the OpenJDK project, but if you really want a solution, you need a company like Azul, Bellsoft, others, to really solve it for you if you really need a solution. And that's why we have different build numbers, because in between, we also make builds for customers with a specific fix if they have found something which needs to be fixed. By the way, I never can exit Vim. The same happens with JShell, it's /exit. If you learn one thing today. And it's a good question, yeah. I promise, good question. All 1902s are the same because they're based on the same OpenJDK, but they can still be different. Like we have a build of Zulu 1709.CRaC. So that's the same one as the one that everyone has, but we have added CRaC in there. So you can find different versions with the same number, but something additional. And that's what, for instance, is happening with CRaC. Okay, now the story about warm-up. Java was designed and created to run everywhere. That means that we need to find a way to distribute our code in a way that it is recognized on every system, on every runtime. So what happens is you write Java code, then you go to the Java-C, the compiler, and it generates bytecode, class files. Now, this code is the code that's being executed by Java. So Java can recognize this, knows what to do with it, and will execute your program. Okay? Since Java, I don't know, you can execute a Java file directly with Java, but actually it will use the compiler again, so you have this cycle. The cycle is hidden for you. It's one of these improvements which is ongoing to make Java easier for newcomers. Since Java 21, we also have a preview feature that the main function has been very simplified. I have a blog on Fuji about that. But warm-up. So what's happening with these class files, these bytecodes? If your program starts and it starts executing your code, it executes this bytecode, the yellow block here, the yellow part. And this code has been compiled to a format that is recognized on every system, on every platform, on Windows, on Linux, on an ARM processor, on an Intel processor. But it's not efficient. It's not optimized for the platform you are running it on. So what Java will do is count every method. How many times has it been used? And I think the threshold is 5,000. If a method has been called a certain amount of times, it will compile it to native code, code optimized for your platform. But it will do this as fast as possible. And then you end up in the green zone, and your code becomes better, faster. And again, Java will count how many times is this optimized code used, and more importantly, how is it used? If you have a switch case with 5 cases, and 2 of them are never used, then it will ignore these 2 and add an error in between. And it will again compile this code to better native code. It will take more time. And you see some drops here, and that's at some point your application needs the 4th case which was dropped out, which an error handled. So it comes into the error, it says, I had to compile it, so it will go back to the bytecode, compile it again, and then you have your optimized code. So at some point, you reach the maximum performance that can be achieved with that code. The drops here are the garbage collector. Use Prime if you don't want that. And this is important to understand. As a Java developer, I ticked the microphone, I hope it didn't. As a Java developer, I've never been aware of this. That was not, as I mentioned before, I'm not an educated programmer. I just learned it by doing it. I think I have tried to solve problems which were actually this, because your application starts and it is not fast enough. And this is pretty important now in, for instance, a cloud environment that you have created that should be scalable. So if your application is here, it's running smoothly, it's running perfectly, but you have too much incoming traffic, reservation system, a spike, whatever, and you start a new instance. But this new instance starts here. So again, it has to learn. And it will take some time before it's ready. So that means that either you have to lower your threshold to start a new instance, or in the worst case, too many instances will be started. And you end up with a system which is taking up too many servers resources, while actually it's still warming up. Or if you have an application which you only need from time to time, or some batch job or whatever, each time it starts here, while you want it to start here. And how can we solve that? So this is another visualization of this cycle. So when your application starts, you have the interpreted code, the bytecode. It starts profiling it. How many times is this code used? It compiles it, but fast, with low optimization. Then it does some profiling again to find the hot code, the hot spots. So which code is used the most in which way? What code elements can I just drop? And what can I optimize? One of the good examples is if you have an if case and you never end up in the else part, then why should you compile the else part? That's the kind of stuff which is dropped out. It takes more time, but then you have the best possible code. And in case the optimization made a wrong assumption, it will de-optimize and make the cycle again. So this is an important thing to understand.
Does it keep a history of the optimization, or will it?
No.
Will it use
And that's the problem. So and that's why each time you start your application, you start here.
When I mean in the same, if you go through the cycle.
If you're in the cycle, the Java is smart enough to know, I made these assumptions but I need the extra case, so I will add it to the, now there are two different warm-ups, and so if the JVM starts, it's actually just the JVM itself, the Java application, which starts. Then it loads your application, so it will need to load all the classes. And then you end up at the main entry point of your application when you start executing code. So actually, if you look into documentation about warm-up and startup, you will sometimes find them mixed up. But actually, you have a startup of your JVM and your application, and then you have the warm-up, which is longer, because it's only after code is actually being executed that it can be analyzed, that the hotspots can be found, and that it can actually find the hotspots and compile it and make native code out of it. Now, one solution, instead of just-in-time compilation, is ahead-of-time compilation. By the way, I forget my present. GraalVM. Why shouldn't we all use GraalVM? What is GraalVM? Everyone knows it. It's an alternative to OpenJDK. So the idea is of GraalVM, instead of making code that can be executed on every platform, we know we have a production system and it's only running on a Linux with an Intel processor in Amazon on that type of machine. So we don't need code that can be executed everywhere. So let's build, in our build pipeline, instead of a jar file, let's build a native Linux application for this specific Linux and processor. So that means that we are moving this whole part which is happening in the blue part with the compiled code, the native code, we are moving that to our build pipeline, not to the running build. So we don't need to interpret the bytecode at runtime. We don't need to find the hotspots. There is no runtime compilation happening, and we can start in the blue zone directly. That's the idea. That's the idea of GraalVM. Of course, there is a but. Otherwise, I wouldn't be here. And I even, Simon, who has written the book, has a talk, I think it was at Devox last year, and I've written a blog post about it. Actually, having this system of compiling the code at runtime is the strong point of Java. It can adapt your code to work as smooth and performant as possible for the use case. Again, go to this switch with 5 cases. GraalVM will compile the 5 cases because that's in your code. If your system today only uses 3, it will optimize for those 3. But if your system tomorrow needs the 4th use case, it will re-optimize it again. So your system can adapt according to the needs. So it is able at all times to go back to the bytecode and recompile it to be the best possible solution for your use case at that moment. With ahead of time, you lose that capability because the bytecode is not there. There is no possibility to convert bytecode into native code anymore. And of course, yeah, I said it's moved to your build pipeline. That means that if you're running your application in different environments, you need to build it for each environment. And actually, from eco-friendly point of view, apparently it's also an issue because it takes a lot of energy to do this upfront. So it's not, there are different reasons. But I talked a lot with visitors at the booth of Azul, at both Devox and other conferences. People who are experimenting with GraalVM are having quite some issues. Of course, it's a technology in evolvement. They will find solutions for a lot of these things. But not having the bytecode is one of them. It's not always as performant as they hoped it would be. And if they compare it with the same code, exactly the same code, but just as a jar file, and they do load tests, they find that it's more performant at the end because it's able to adapt to the use case. So it's software. What is the best solution? It depends. And you have to try it out. But with Azul, we were looking for a solution to start here. Can we somehow make our system always start there? And keep all the advantages of JIT. And we have a solution already for quite some time, but it's inside Prime. So Prime is the commercial offering of Azul, and only for Linux systems. And it's called Ready Now. And what is it going to explode? What Ready Now is doing, it's keeping profiles. It's keeping profiles of how is this code used and how should it be optimized. And then you see that that this blue line, this is the best result that you can have. The graph is vice versa than the other one. But you see that with Ready Now, we can start immediately at a good point. So we have a lot of companies using this. Other companies who are not relying on Ready Now, like for instance in stock exchange, we have customers who need maximum performance when the stocks open. So they start their servers hours before, do dummy trades to warm up their systems. So that's something which can solve with a technology like Ready Now. But for Azul, we had customers asking for a solution which is not based on this heavy Linux servers running in the cloud. And then we're talking about infotainment systems, about cars. I know my car has 3 Java licenses in there. One is for the infotainment system, then some gateway stuff. So there is a lot of Java in devices that we are not aware of, which is actually a bit strange, as Java was originally created for set-top boxes, for the Telenet decoder that we have under our television. That's also running Java. That's why Java was created 25 years ago, to easily make software for this kind of devices. So it's a bit strange that somehow in the history of Java we drifted away towards mainly server applications, while this is really a big market still, because it allows you to create Java applications very easily for this kind of devices. So we were having companies looking for a solution for this kind of devices on embedded platforms. Then some strange guys like me experimenting on Raspberry Pi. We also want fast startup there. And that's where CRaC comes into the picture. So CRaC is an evolvement of different projects which were done within Azul. CRAM was one of them. And the idea of CRaC is, and every word is important here, coordinated restore at checkpoint. By the way, CRaC is a name which was also invented by Simon Ritter. There's some discussion if it's a good idea to have that as a name, but let's not go into that discussion. What is the idea of CRaC? So you have a running application which is at that blue part of maximum performance. At that moment you can take a checkpoint, a snapshot, a copy. This is my running application. She's working at maximum performance. I want a copy of it. That's the checkpoint. If you create a checkpoint, your application stops. So you have then a checkpoint that you can reuse, and you can restore it. You can restart your application from that point on the same machine or on other machines. So if you have a scaling application, you can scale it from that checkpoint and have multiple instances doing the same application. But the coordinated is also very important here. It's not just taking a copy and restarting it, because there are some things you want to do when that happens. When you're creating a checkpoint, you want your database connection to be closed. You don't want to have an open connection using some resources which are no longer needed. A log file, close a log file, close a network connection, all that kind of sockets, that kind of things. That means that if your application restarts, that you also need to know that it has restarted, that you have to reconnect to your database, that you have to reconnect to your network or your file or log file. So all these parts are handled within the CRaC project. It's something which we have been working on for many years. It's inside the OpenJDK project, so it's now an open source project also. It is driven by Azul, but it's really an open source thing. And on May, we officially launched this with this graph. So these were the test results that we had. Because it's coordinated, your application needs to do something, it needs code changes. So these frameworks didn't support it yet. So these were initial tests with forks of all these frameworks. But still you see that within 40 milliseconds on average, you can restart an application which was warmed up before. Okay? I'm looking at the time, but he said we have to leave before 10:30. Will not take that long. So let's add CRaC to a project. It's Java, means it's the library, Maven repository, org.crack, artifact is CRaC, the version is I think 1.4, and you get 2 overrides before checkpoint and after restore. So that means that in this override, you can, for instance, close your database connection and reopen it. That's the only things you need to do to change your application. And yeah, because I worked on the docs of CRaC, and I am the Java and Raspberry Pi guy, within 5 minutes, someone asked me, can I do it on Raspberry Pi? So I tried it in April. A long blog post, but the conclusion is no. And then I'm lucky to work at Azul because I could ask to the engineer who wrote CRaC, why doesn't it work? And then he asked for some logs, and there were a few issues. There was a problem in the library itself, which was quickly solved. But the main problem reveals how this works. In Linux, you have the CRaC system. Don't know if you know it. That's actually the thing which can make a checkpoint of any application. So it's like in Windows, making a sleep function. So hibernate, yeah. So and CRaC needs to be enabled within the kernel of Linux to be used. So they say at some point that every developer using Linux compiles the kernel. That was my first time. So to be able to test this, I had to compile the kernel of Linux, which actually also is just as easy, I found out, as compiling OpenJDK itself. It's just following the README. And at some point, enabling one option. And enabling this one option, and this is why I love open source. There is a GitHub project, again, within the Raspberry Pi project for the Linux kernel. So it's a specific build of the Linux kernel for the Raspberry Pi. There's one guy maintaining that. So I tried to describe it. He got back to me, and he said, yeah, the change is 5 kilobytes. I don't know why, it's just one option, but it's 5 kilobytes. I don't see a lot of impact, let's do it. So just stepping up and trying out, and the only thing which is important if you do something in a project like this, which is huge and gets a lot of tickets, is to really follow their template. If they provide a template to make a bug request or a ticket, follow it and be clear. Give code examples. What have I done? What have I tried? What did I see? What did I expect? What didn't happen?
It's now officially enabled.
And it's officially enabled. Come to that. So it's this change. It's just one line. When I checked back to the project some time ago, because we had a new version of Zulu built, I saw that they created a label, a tag on this project. The tag was on the 4th of October. And it has a lot of changes, but that's mine. Actually, is it here? There are 5,000 files changed with 100,000 additions. So I didn't know that the kernel of Linux was such a a major project because they forked from the main project, so it's really big. And why did they tag it in October? Because they released this one, the Raspberry Pi 5. It's based on a new processor, so they needed to recompile the kernel, and they were going to start deliveries on the 23rd of October, I think, which of course was delayed. But they were building a new version for that board, and they have also the approach that the operating system is backwards compatible with the older boards, so it's the same build for all the boards. Of course, I ordered one when they when they announced it, and I have to disappoint you. It's still in the box, and I received it last month. It's the season of the conferences and the talks, and a lot of work to do. So it's waiting to experiment. But actually, the Raspberry Pi operating system is based on Debian. Debian also has a new release, which is called Bookworm. So they brought everything together, and in that version. I tested it again on the 16th of October on the Raspberry Pi 4, and it works. So if you follow this guide, it's just with a simple demo application, you can try CRaC on Linux. Why do you need to run it on Linux? Because at the current moment, CRaC is only supported on Linux systems, because it uses Creo, which is part of Linux. Now, I come to the next steps, but at Azul we are working on a JEP, which is a proposal to bring it to OpenJDK, and at that point maybe we could involve more people who know a way to do also this kind of things in Windows, in Mac, maybe even step away from Creo on Linux to find an approach which works on more systems, but we're not there yet. But there is definitely a request to also be able to do this on other systems. Because you add it as a library, the library will handle it if you try it on other platforms. So you can still have the function before and after restore. It will don't do anything, but it can be there. So I have a little demo application, and I show you the code. If it works, yes. So I created an application which has a very strange use case. And the idea is really to show you things which need to happen during warm-up and which then can be called and should be very fast. So I have zip files with a lot of records, from 1,000 to 500,000 records. So each line is one record. What the application does is when you request one of these files, they are zipped. It unzips the file, it converts every line to a Java object and keeps it in memory. And as soon as you request it again, it just can take it out of memory. And it is a little application which also uses Jetty. So it has a server, it has a database to log how many times was a file requested, and it stores it in a Postgres database. And here you see the CRaC specific code. So what you see here is that when your class gets created, initialized, you have to register it with the core so that it knows which classes to monitor. And a bit later you see, so before checkpoint, it will close the connection to the database, and after restore, it will initialize the connection again. So here you see these elements are CRaC specific code. So here it will do something. And the same happens with the Jetty, with the web server. Again, here you have the register. You have the before checkpoint that all the connections get closed, and after restore that all the connections get opened again. So this is a very small demo application. My colleague Gerrit has also written something like this.
How we can know when is the best time to do the checkpoint?
It depends.
So to not lose too much CPU, but be the best.
There are some tools like JFR, where you can monitor the usage of your application, Java Flight Recorder. That's one of the things that you need to do. You need some kind of use test case to do this, that you have a certain latency. Well, my application has to reply that fast, and that you can test it, that you can measure it. And I have to be honest, that's always the most tricky part. For instance, if people are evaluating Azul Prime, which comes with the costs, and they are considering it compared to another OpenJDK distributor, is how do you measure the performance gain of an application, of a runtime? First, you need really good tools to measure something, and that will depend on your application. If you have something which an order handling system, if I send an order with 3 lines, I want it to be processed within that amount of milliseconds. And that's something you will need to test in your environment and, and have some kind of tools to test that. But it's a difficult question. We advise people that are evaluating Azul Prime to wait at least 20-30 minutes to measure latency. And then the application needs to be under full load before reaching that point. This is my last robot, Duke, sorry. Yes, you still have a question? I have 3 books, that's all.
You mentioned closing files and reopening them on restore, but don't you have like requirements that the file must be at the exact same state when you close it?
Yeah, again, it depends a bit. If it's a log file, then you maybe need to flush it.
My question is more like if you're logging to a file and then you take a snapshot and then you restore it on another server, which
yeah. There is a way, and I think we still need to add it to the documentation, is that you can provide some arguments for the restore, where you can define log it to this file, for instance, for stuff like this, so that you can reconfigure some things specifically for that platform. But the easiest thing is that you make a snapshot for an exact same environment, which is not always the case. That's also why we have in the documentation, because it's native code that you are snapshotting, it also should be started on the same platform and processor.
That part is fine.
Yeah.
Even if you restore on the same machine, but the log file has been rotated,
and I think that was the problem with some of the Micronaut and the Spring things.
I know.
Yeah. It's actually a problem of the framework on top of it. And that's something which is being handled now, like for instance, Spring has now support for CRaC. It's something they are solving, like having resources that they are handling it within the framework that you do.
I don't think we are solving anything. I'm working on the Spring team. So.
Okay. I have a blog post.
That's why I'm asking you the logging and...
I don't know. I can check with my colleagues and come back to you about that. Okay. Yeah. Yep. So what I have here is a recording of this application on the Raspberry Pi. So what I did is I created a jar file of this application. So what you need to do to start an application to be ready to create a checkpoint is that you give it the location of where you want the checkpoint to be created. So this is the directory. Okay? This is part of the start command. Now, when the application is running in a second terminal or in another session, you can use J commands and the target application and ask it to create a checkpoint. So at this point, the checkpoint creation process will start, and if it's finished successfully, your application will be stopped. And if you have a checkpoint in that directory, you can restart it with CRaC restore from and the directory where the checkpoint is found. So you see here that if you would have extra arguments here, they would already be stored in the checkpoint, and you cannot specify them here, and that's why, but I think we need to document it still. You can overwrite it here at that point. So this is on a Raspberry Pi. So you see the CR directory is still empty with my checkpoint. In the first terminal, I'm starting this application. It takes about 5 seconds to start, so it's this Jetty with the Postgres connection and some logging. And then in the browser, I can ask the list of these files. And if I ask one of the small files, so it's a zip file, it gets unzipped. Yeah, it's going too fast. It's loaded in 56 milliseconds and then creating objects of it. Within 700 milliseconds, we have the result of the smallest files. But then if we go up, at the end, I'm loading a file of 500,000 records, I think, or 50,000, yeah, 500,000. It's beginning to take some time, 7 seconds. So this is the initial call to these files. Load them from the zip, unzip them, and create records from every line within this file. And the last one, you see it stays white for quite some time. We have till 10:30. It's taking 50 seconds. So, but as soon as these files are loaded and I go back to the list and I load the longest one, you get the result in 8 milliseconds because it's loaded into memory. That's what. So this application has not been fully warmed up because I only called each method a few times, but it actually loaded already data into memory, and that's the kind of thing I wanted to achieve here. Okay. And now in the second terminal, so my application is still running, we're asking through jcommand to create a checkpoint. So you see here, recording is available, it's busy creating it. So here it's already seen, it will be done, but it's still ongoing. So this also takes, I think, 7 seconds or something like that. And in the end, my application is killed. So I cannot load my web page again because the application is gone, okay? But we have the checkpoint. So the next movie is restoring it from the checkpoint. You've seen how fast this was? Let me go back. So the previous time, this took 5 seconds to start the Jetty and the whole thing. So you see when it's not highlighted anymore, puff. Within a second, there is no timing really here, but the application is available. So we already gained that 5 seconds from the start. And now when I request the biggest file, because everything was already in memory, it has reloaded everything from into memory, we get again 6, 4, 15, 5 milliseconds response times for this application. So very fast. And again, on a Raspberry Pi with 2 gigabytes of memory of 30 euros. So you don't need a heavy Amazon machine to run this. Dump for log, at this point the logging level is at 4, so meaning that if you create a checkpoint and something goes wrong because you have somewhere an open connection, you will find it in this file, which is one of the many files which is created in that directory. So what is the current state of this project? At this moment, it's a project within OpenJDK. That means a project within OpenJDK is a research. This is a good idea, we think. Can we find a community? Can we create an example? And are people interested in this? That's the idea of the project. So this link actually takes you to the GitHub projects and where you can find extra documentation. The idea is to create a JEP. You know about the JEPs. It's a Java enhancement proposal. The idea of a JEP is that it comes into OpenJDK at some point. Most JEPs arrive in OpenJDK. So it's really an improvement, an increment in OpenJDK. It's not a bug. A bug is something which is easy to fix, hopefully. a JEP is really something new. And something new means there is some work to do here. It's not putting a comma somewhere at the right place. It's really a JEP, an enhancement proposal. And how can you know JEPs? Because, for instance, in OpenJDK 21, there were a lot of them. The new features which were brought into OpenJDK Java 21 were 1, 2, 3, 4, 5, 6, 7, 8 finalized JEPs. JEPs which are finished. They are now available, completely integrated. There's an improvement in ZGC, there are improvements in record patterns, there are improvements in pattern matching for switch. So if you go to JEP 440, you will find the full explanation. If you go to Fujay podcast, we have a podcast about this. But JEPs get into OpenJDK, but not always fully implemented and ready to use. Because also in 21, there were seven incubator and preview features. That means they are there, but you cannot use them. You can only use them if you start Java with enable preview. Also, if you're coding in IntelliJ, you will have to select 21 with preview features. Otherwise, your code will not compile if you use any of these features. And for instance, here is my favorite, unnamed classes and instance main methods. You can now create a Java file without a class and with just public main brackets. No string argument thing. It's very easy for newcomers. That's why I love it, because I have some tutorials about this. But it's a preview feature. Vector API is the 6th incubator. So it's the 6th time that they add a version of the Vector API in OpenJDK, which is not finished yet. So that means that's already there from OpenJDK 15. There has been a version of the Vector API implementation. So why? And actually, that's an amazing thing that they've done since they introduced the 6-month release cycle of Java. They can get feedback from the community this way. A lot of people are very interested in what's coming into OpenJDK, like the virtual threads, which are now here as an implemented feature. They have been in Java for quite some time already as previews. So people have been using this, have been building Spring versions which already implement this to test it. So now that it's ready, they can really finish it and implement it with the final version. So also for this main method improvements, there were some remarks on how they implemented it. So in version 22, there will again be a second preview of another JEP which has an implementation of the same method improvement. So that's something also to understand about OpenJDK and JEPs. So we hope to have a JEP about CRaC also here soon, but it's not on the screenshot. You also have another project, Project Leiden. Someone heard about that? It's also about startup of Java applications and how you can improve that. So it's also a research project, which aims to do a bit the same of the things that CRaC is doing, but CRaC is already here, while Project Leiden is still a research project, and maybe 24, 25, that version will have some kind of implementation, or somehow CRaC and Leiden can merge into some JEPs to bring the same things to OpenJDK. So that's still stuff ongoing. Now, if I got you interested in using CRaC, coordinate restored checkpoint, that CRaC, then you can find a lot of information on docs.azul.com. There we have a whole section about CRaC. It already has been used by Amazon in Lambda. So if you upload a new Lambda, you can select an option, snapshot, and what they actually do is when you upload your jar file, they immediately execute it and they take a snapshot, that checkpoint. So the next time your Lambda is called, it's actually the checkpoint which is started. So they have already implemented CRaC into their runtime. And it's also implemented in Micronaut, Quarkus, and Spring Boot. So there are now versions available which have an implementation of CRaC. And my colleague Garrett has blogged about this, I think, last week. And these are the results. Now, let's dive into his article. And there was so it's in Spring Boot 3.2 it's implemented. And actually, there are two ways you can use CRaC in there. And there is the automatic checkpoint. And actually, it's well described. So if you add an extra parameter, property, it will create automatically a checkpoint at startup during the life cycle process. So that means that all the singletons have been instantiated, but nothing has started yet. So it's, you can imagine somewhere at the main of your application that Spring is already taking a snapshot. So you can start from there. But still you can use the same thing as I've shown you before with J-command, that you wait longer and then manually create a checkpoint, and that's how you end up with these different charts. So without CRaC, switching from 17 to 21 already brings you a lot of speed improvements. And then the automatic checkpoint is 1/10 of the time. And the manual checkpoint later in the application, which is a bit more complicated to do, brings you more improvements. So this is the blog written by Garrett. I invite you if you want all the details. I've mentioned the name Fujay a few times. Who knows Fujay? Oh, almost everyone. I have stickers of Fujay. I also have stickers of the Belgian jug, although we are in the brew jug. Friends of OpenJDK, Fujay. The website was started by Gert-Jan by initiative of Azul, but it's actually a community effort. It's a project for the Friends of OpenJDK, companies, developers, writers, users, anyone. We have Fujay today. 1, 2, 3 articles per day are published there. If you have
for the last 3 years.
Huh?
Every day
for the last 3 years. We have over 200 people who have contributed at least one article. If you have written something about Java, about Kotlin, about OpenJDK, about something, a new tool to use in IntelliJ, whatever, something which is for use of other developers, and you've written a blog on your post, on your own website, or you're looking for a place where you can publish it, let us know. We invite everyone to contribute here. I eventually got a job at Azul, thanks to my contributions here and knowing people. Like for instance, my content about experimenting with Java on Raspberry Pi is also here. And I also create a podcast, 1, 2, 3 a month, depending on. I have podcasts. If you want to know the history about the brew jug, one of my guests is here in the room. So that was the session of June, it was just before the summer we talked. But also Stefan Janssens, who started the Belgian jug and is now the organizer of Devox, and who is living of organizing a conference. That's a really fun story. By the way, Devox started as Java Polis. I mentioned something about the trademark issue with the name Java. That's why it's Devox. Okay, I went way over my hour, but still not 10:30. If you want to know more about what I'm doing, you can follow me on Fujay. I have my own blog on webtechy.be, and of course everything related to Azul, Zulu, and CRaC, you can find it on docs.azul.com. And definitely, if you take Raspberry Pi and start experimenting with all this, it's a lot of fun. It's also a lot of fails, but yeah, that's how you learn all these things. Okay, that's it for me. Questions?
Thanks for the presentation. It's really good.
Thank you.
I guess my question was that you had a pet project that you load up quite a lot of records in memory.
Yeah.
So it obviously takes up a certain amount in memory. What was the size of the checkpoint when you did that?
That's a good question.
Just more or less, like, you know, if it's a ballpark figure that it's like your 200 megs of data that you have in memory, and it ends up that the checkpoint is 20 meg.
Actually, that's something I'm going to write down. I didn't measure it. It's somewhere still on my system, but I don't have it with me, so I need to write this down. I will add this to my blog.
Okay, sure.
Yeah.
And then I guess the other follow-up question from that is that once you have a checkpoint, is there any tools that you can verify the checkpoint is valid? Because, for example, I suppose the CRaC part is just delegating to CRIU, so coordinate, restore, and user space, basically on the Linux system. But do they have any tools that say if this checkpoint has been garbled or manipulated, then you can't, it's not valid, you can check somewhere?
Not at this point, because, as I said, we are relying on that CRIU, but that's not really the way forward. That's the solution now. So we also want to find a solution for Windows, for Mac. So we don't want to invest a lot in that CRIU. Mm-hmm. How do you know that it was created successfully? Because your application was killed. Every error I had resulted in some kind of log messages and my application just running half because my database was closed, but other things not. So if the application is still running somehow, then the checkpoint was not okay. And the easiest way is just restarting it. But yeah, having a tool to validate it is, yeah.
Yeah, so if, for example, you took the checkpoint and then say you have a ARM64 on a Debian, and then you want to take that checkpoint, put it onto a Ubuntu ARM32, and then you load it, you know that the checkpoint isn't going to be valid at restore time, but you don't know, just looking at the checkpoint files, you can't say that's valid or not.
You will have to try it on that other system. I think, I'm not sure if you added it already to documentation. There are some flags that you can set if you're running it on another system. It's the CPU features, I think. Yes, here you can define which, but what you're telling here is that some optimizations and native codes should be ignored. So that means that you're actually telling your restored application to go back to the bytecode. So you're actually losing a lot of that blue part and going back to the yellow part. So moving from one architecture to another doesn't really fit this use case. Yeah.
But if you were to say so the architectures are saying being ARM64, but if the Linux kernel is slightly different, then it'll be useless as well.
It could have an issue. Yeah. But yeah, where we see this is, for instance, in scaling applications, and typically, if you scale it, you're using the same underlying architecture. So
in a CI/CD pipeline, for example, you say if you have a Debian and a Ubuntu, for argument's sake, you can set your target systems, create a checkpoint, and then save it.
And group them differently. But it's still a project within OpenJDK, so it's not final. So that means my colleagues who are actually working on this, I'm just talking about it, are really listening and waiting for feedback. How are you going to use this? And if that is a real use case to move between architectures, then a solution will be needed. We already have the CPU features, but it's some kind of solution, but not a perfect one. But if we can find better ones, then it's definitely a possibility.
I have a question about the level of control that you have on the class you don't own. So typically the class in the JDK, because there you cannot define those two additional methods. So for example, the date times and things like that, or the random, because you would typically want to change the seed from one run to the other. So, because those could have both implication in terms of security, but also in terms of performance, because I can very well imagine that if you have an issue at a given state, for example, that you would want to take the same image and run it locally on the same infrastructure and OS, but telling the program to behave as if it was that point in time.
I think that's the reason why they want to have additional options you can give if you restore it. That you can give the seed from another way, for instance. And then you can have some, after restore implementation, to reinitialize your random with that seed, for instance. That could be a solution. But yeah, indeed, the internal functions, no, you need to implement it somehow that you can reconfigure it in your after restore. Yeah. I'm writing down the questions because I'm just giving them to my colleagues. Okay. Yeah.
Yeah, my question is a bit related because indeed in the example on the Raspberry Pi that you showed, you keep the state of the application like is there a way to just keep the optimized code, the compile optimizations, and lose the state of, or would you just have to do it manually?
You would have to use it differently. I really created it this way because I wanted an example that I can restart, that I can start fast, and I don't really need to warm it up. I needed something to be stored in memory. It's not really how you would use an application like this. This would be normally in a database, for instance, and loaded from database.
But in general, if you make a checkpoint, you make a checkpoint of the state of the application at that time.
Yeah.
So if
but
it's a stock trading application, it's the state of the stock market.
But I could have done in my before checkpoints a clear of this list where I stored everything.
So then you need to do it manually.
Yeah. Then you need to do it manually. Yeah. But yeah, it's I find it a very interesting thing to experiment with, and that's how I think most of our users nowadays, that's the state where they are experimenting with it. But there is really a lot of interest. Like people having the blog about Spring in 3.2 of Spring Boot, I think it was one of the most viewed web pages of the last months. So there is really a lot of interest here. Because that warm-up and being able to scale very fast is a hot topic. And it allows you to keep your servers smaller because you don't need that warm-up time. So you are already at maximum performance. Okay?
But that could be a follow-up question because, well, when you define your application, you define the heap that will be taken by the application, and then on top of that, you have the memory for the Java process itself, maybe some off-heap if you have tools like Azul or other that do that, plus the garbage collection memory. Is there a reduction in terms of total usage of memory when you
think so.
do? No?
I don't think so, no. Good question. No, because actually it wants to create a snapshot, the checkpoint as fast as possible. So it's just taking it from the state it is. I think it's how it's implemented. Okay. Thanks a lot.
Thank you.
I'm gonna put the stickers here. Do you need